Okay, so I'm going to briefly explain how ZTNA service works, which is Zero Trust Network Access. Okay, so let's begin. Okay, so Zero Trust Network Access, ZTNA, is an approach to providing secure access to resources such as applications that focus on strict access and security measures. So ZTNA operates under the principle of never trust and always verify, which means that no user or device, whether inside or outside the network parameter, should be automatically trusted, right? Instead, ZTNA verifies and authenticates every user and device before granting access to application or resources, regardless of their location. Yeah, so this is a more modern approach. In the past, what would happen is anybody inside the corporate network automatically has access to the resources, right? And typically more resources than they actually need. But the ZTNA service works on the principle of least privilege and per application level type of access. So if the user just needs one application to do their job, then they will be only given access to that application and not to everything inside, not to all the resources in the corporate network. Okay. Okay, so the way it works is, so the user that they can connect either to managed devices or unmanaged devices, in which case the access will be through the browser. And those obviously, when it's a browser is used, then the protocols supported are limited to whatever is supported by the browser, right? Okay, so before granting access, the identity is verified and to either an Active Directory or identity provider or some other solution, right? And also includes multi-factor authentication. Okay, so besides this, what makes ZTNA different is it also adds additional layer, right? So it also checks the context, right? So in this case, it will check the device posture. So let's say the certain version of the operating system is only allowed, so it will check the operating system version. Maybe only certain type of browser is allowed, so it will check the browser version. It will check for example, if it's a Windows laptop, it will check the configuration, which must match the compliance standards. We'll also check the patch status, antivirus, spyware, where the encryption is enabled, while firewall is enabled. So device posture, and it will also check location, where the user is located, what time the user is trying to access, and frequency of request. So these are some of the contexts that adds an additional security check in a ZTNA access. Again, the concept of ZTNA is least privilege, so only give access for the user to do their job. Continuous verification means that even when the session is connected, there will be continuous verification. For example, if the IP changes, then the access will be terminated, or if the location changes, or then access could be terminated. Also, again, this is application level access, right? So not give access to the entire subnet or the entire and all the resources, right? Like typically in the past, right? VPN would be used, which would give access to the entire, for example, the subnet, and which could host many applications, right? So in this case, the so micro segmentation can be done, and application can be hosted in that segment. so that other applications are not accessible to the user. Okay, so once all this context-based access check and identity and all that is done, at the ZTNA service, which could be a access proxy or a device, access policy is defined, which maps the users to the application. So the applications could be the users could be a role could be defined, right? So a certain role can access um, application, right? Okay. So the important thing here is how does the application connect to the ZTNA service? So here it's a little bit tricky. So the application in public cloud or private cloud or in a private data center, right? These orange orange squares that I put here, these symbols are for an application connector. So what happens is these application connector make an out from inside to outside request, right? So the request doesn't go from ZTNA service to the application. It's the other way. So the request is for the access is granted by an outbound connection from the application connector. So this means that the firewall doesn't need to allow any open any inbound ports, only outbound ports just for the for connecting to ZTNA service will be allowed. So this adds an additional security, right? Because then the inbound ports can be blocked, and so various so there's no more exposure to the public internet, right? So attacks such as DDoS can be prevented. So so again, outbound connection here goes here, and then this way the user is connected. So yeah, this is it. Again, it's just a quick summary is managed devices or unmanaged devices can connect. Doesn't matter if they are on-prem or in a cafe shop or whatever. Identity will be verified, and also context space check will also be done. The access will be leased based on lease privilege. There will be continuous verification, and this will be application level access. So smaller chunks of segments where the application is running. And the user is, in fact, the user doesn't even know where the applications are located. They are the underlying infrastructure. So when they connect, the application might be hosted in a public cloud. It could be in a private cloud. So they wouldn't know. They would just get the access to the application. So yeah, this obviously with all these checks and this is a more secure way of connecting.